to 11. We have to multiply. If you're stuck and not sure where to go from here, you should refer back to the examples. So I would turn back to example 1 for this top row, which is on page 203. First step was to divide by common factors. They showed you that they took out a common factor of 3 from a top factor and a bottom factor in our problem. Then they multiplied the numerators and denominators. Then they simplified. Guys, they're giving you step by step. You just need to do it, right? You can't just sit there and pretend like you don't know. You need to figure it out. Try, put forth some effort. So looking across these diagonals, 1 and 5, we can't divide by anything but 1, but 2 and 4, we can take out a factor of what here? 1. If I take out a factor of 1, it doesn't change my number, right? Anything divided by 1 is that. 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. Now I would multiply across the top. 1 times 2 is 2. 1 times 5 is 5. Negative times a negative is positive. So all of those top answers will be positive, right? I'm not going to do all of these for you. You need to go through and review. If you need help multiplying fractions, you have a Chromebook. Type in multiply fractions. Go back and rewatch the videos in Google Classroom. Practice it along with whatever you're watching. Don't just sit there. Walk through the examples and reveal. There are so many options for you. You need to have a little grit and put forth a little bit more effort. Many of you. Some of you are doing fantastic. All right. Whole number times the bottom number. 1 times 9 is 9. Plus 4 is 13. We write that out of 9. Then I'm still multiplying, so I can't forget my multiplication sign. And I have a negative something. So 2 times 7 is 14. 14 plus 4 is 18. So I'm saying 13 times 18. Well, that seems like a big number. I realized I forgot to go across my diagonal. Here I can't take a factor out of either of those. They're prime. Here I can though. What can I take out of 9 and 18? 9. So 9 divided by 9 is 1. 18 divided by 9 is 2. 13 times 2. Now that's something I can do in my head. And 1 times 7. Now I would change this to a mixed number. And I have to remember that it is negative because positive times a negative is negative. So this is going to be negative something. Well, I know 7 goes into 26 how many times? 3 times without going over, and 3 times that 7 is 21. So 26 minus 21, I have a remainder of 5, and I write that over what I was dividing by. So there's 2 good answers there. Okay. This section, it says to go back to example 3. Now, they only gave you one that you have to change to fractions. These others you could change to decimals rather easily. But 1/6 I can't change to a decimal. So I have to change 2 and 4/10. If you can say this, you can write it. So I have negative 1/6 and I have 2 and 4/10. I could leave it like this, but I actually have to change it to an improper fraction first, right? I don't have to necessarily simplify that, but I could. I could write, what, 2/5 if you want. Let's just pretend like we're not going to and change this to improper. So 2 times 10 is 20, plus that 4 is 24. So I have 24/10 times negative 1/6. Well, right away, I know that 24 is a multiple of 6. So I can divide these both by 6. 6 divided by 1, 24 divided by 6 divided by 1. 6 divided by 6 is 1. 24 divided by 6 is 4. Now I'm just multiplying. Or, you know what else you could do? You could simplify this, but you're going to get 2/5. So if I multiply, I've got negative 4 over 10. This is not simplified, so you would have to go one step further. Divide the top and the bottom by what? 2. So you should have gotten negative 2/5. Now here, you could change to a decimal. You could say 2 divided by 5 in your calculator, or you could say 2/5 is equal to 4/10. So guess what? This is 4/10 times negative 3 and 75/100. So you can leave this as decimals. I would just put them into your calculator. 0.4 times negative 3 and 75/100. Negative 1.5. Or negative 1 5/10. All right. So you're going to have to go back and do the other ones if you have not yet done them. Evaluating these expressions. Okay, remember, our first step is to rewrite the problem. 1/4. I'm putting parentheses in place of my x and in place of my y. And then I'm going to put my x and my y values where they're supposed to go. So my x value, negative 2/3, goes here. And my y value, 3/5, goes here. Now we're multiplying all of these. Right away, I see that these are going to cancel each other out. 3 divided by 3 is both 1. Here, we can take out a factor of 2. Once and twice on the bottom. So now 1 times 1 times 1 is 1. Positive times a negative is negative. Negative times a positive is still negative. And now I have 2 times 1 is 2 times 5 is 10. Negative 1/10. If they're giving you all fractions, I expect you to do them as fractions. All right, you need to show your work. You want to do one more of these? We're having multiple ones more difficult. You want to do 11 or 12? 11? So again, I would rewrite my problem with parentheses in place of my letters. This time I have an x and a z. So in place of x, I'm putting that negative 2/3 again. And in place of that z, I'm writing negative 1 and 7/8. So before we can start multiplying, we have to change our mixed number to an improper fraction. What's 1 times 8? 8. What's 8 plus 7? 15, and we put that all over 8. Let's just figure out right now what what's the sign of our answer is. Negative times a negative is what? Positive. Now we have positive times a negative, which is negative. So our answer is going to be negative. Somewhere down here, we're going to have a negative number. All right. So now I'm rewriting all of these negative. I'm not writing the negative anymore, right? I figured that out. So just one last thing to worry about recopying all the time. 4/5, 2/3. All right. So look along your diagonals. What can we cancel off? Let's start with the 4. Is there anything on the bottom we can divide by 4 or by 2? Yes. So 4 divided by 4 is 1. 8 divided by 4 is 2. Let's look at our 2 now. Is there anything we can take a factor of 2 out? No. There's not? 2, right? So we could take out another factor here. This is getting really small. Look at our 15. Is there something you can borrow one? Just grab that. Yeah. Yes, we can divide it by 5 or by 3. Which did you do? Okay, so if you do it by 3, you have a 5 here and a 1 here. Now, can we get rid of our 5s? 5 divided by 5 is 1. Oh, this one got really nice. 1 times 1 times 1 is what? 1 times 1 times 1 is what? What's anything divided by itself? 1. So we actually have a negative 1 here. Whoa. Now, had you multiplied, whatever you had on the top would have been the same as whatever you had on the bottom. So you could have said 4 times 2 times 15. That's what's on top, 120. So that's what we're expecting on the bottom. 5 times 3 times 8 times 3 times 8, also 120. Okay? So if you haven't done 12, try that later. All right, here's the same thing, but this time it's a lot like this second section up here. We have to decide if we can change them all to decimal. Looking at our factors here, can we change this to a decimal? Is it terminating? Yes, we can. So I would rewrite my problem. I'm keeping my negative sign there with parentheses in place of my letters. And then I'm simply putting these in here. This is X. This is Y. Now, while I'm doing this, I'm going to change 3 4/5 to 3 8/10. See, times 2 times 2. Which is 3 8/10. If you don't know how to do that, put in 4 divided by 5 into your calculator and out should pop that 8/10. Now, negative times a negative is going to be positive. So this, all of our answers going to be positive. Into my calculator, I would just put 8.4 times 0.25 times 3.8. And you would have 7 9800. Make sure you know how to do that though, right? So 14 you have, and 15 and 16 should have been done as well. You want to do 15 or 16? Any preference? 16, all right. Table shows the temperature at midnight at Finn Creek, Alaska. At 5 a.m., the temperature changed by half of the current value. So half of that, of means to multiply. Half of negative 13.4. Now, I would teach this a little bit differently. They want you to either change this to fraction and multiply, or change this to decimal and multiply. I would say that 1 times that is negative 13.4, and that really means you're just dividing it by 2. But if you changed this to 5/10 and put that into your calculator, you should get the same thing. It's going to be negative still. So 13.4 times 0.5 is negative 6.7 degrees. And is that half of this? Always make sure your answer makes sense, right? Okay, today we're going to move on to dividing. If you haven't finished your practice for multiplication, that is definitely homework and should be practiced. On page 213 now, we're moving on to lesson 4.5. I can use the rules for dividing integers. Remember to divide rational numbers. We practiced and reviewed dividing rational numbers with Who Killed Mr. Frack. So hopefully we are remembering to multiply by the multiplicative inverse or reciprocals. Remember, we have to keep the first fraction. Fraction. Then we have to change the division to multiplication, and then we have to flip the second fraction. Keep, change, flip. So here are the steps again. Rewrite the division as multiplication by the reciprocal. So they kept the first. They changed your division to multiplication. They flipped this. When they flipped it, the 4 was on top and 1 was on the bottom. So that simplified to -4. Then they just multiplied. Same result. Okay. So here, the reciprocal of a fraction with 1 in the numerator is always going to be the whole number of the denominator. So the reciprocal of 1/2, 1/2 has what in the denominator? 2. So the reciprocal of 1/2 is 2. The reciprocal of 1/3, what's in the denominator? 3. So the reciprocal of 1/3 would be 3. Think of some examples. 1/2, the reciprocal would be 2. 1/3, the reciprocal would be 3. So 1/28, the reciprocal would be 28. So you could write a little equation. I shouldn't write equals. I should draw a little thing here. These are all reciprocals, right? Because 1/2 is not equal to 2. All right, multiply by the multiplicative inverse. So here's your example. They said -2/3 divided by 1/9. They kept the first, they changed it to multiplication, and they flipped that second number. Then they divided by common factors. You have to know how to do multiplication in order to do division. So the solution is to this is what? What did they say it was? -6. Right? 2 times 3 gave us the 6. 1 times 1 gave us the 1. Then we simplified. All right, so check it. First of all, how would I write 12 as a fraction? -6/7 divided by 12 over what? 1, right? That's how I would write 12 as a fraction. So then remember our first step is to rewrite the first. -6/7. Our second step is to change division to multiplication. And our third step is to flip this fraction. So the 1 goes to the top, the 12 goes to the bottom. Now we're just multiplying. So we're following the steps of multiplication. Divide out any common factors. What can I take out of 6 and 12? I can divide by 6. So I have 6 divided by 6 is 1. 12 divided by 6 is 2. Negative times a positive is negative. 1 times 1 is 1. And 7 times 2 is 14. I hope it's not seeming so bad, but if we're still struggling to divide out factors, if we're still struggling with multiplication and division, that makes it difficult for sure. All right, now we're going to look at mixed numbers. So just like multiplication, we absolutely have to change them to improper fractions. If you need to write out the steps, we're going to multiply the whole number by the denominator add that to the numerator rewrite that sum over the same same denominator. So your denominator is going to stay the same. 4 times 5 is what? 20. 4 times 5 is 20. 20 plus 2 is 22. That's where they got the 22 from. Here, 2 times 15 is 30. Plus 14 is 44. That's where they got the 44 from. They rewrote this as improper fractions. Then they kept the first, changed to multiplication, and flipped the fraction. Now they're going to take out common factors. I can take 22 out of both of these, right? That's what they did. 22 divided by 22 is 1. 44 divided by 22 is 2. Then they took out a factor of 5 across this diagonal. 5 divided by 5 is 1. 15 divided by 5 is 3. Negative times a negative is going to be positive. 1 times 3, they got 3. 1 times 2, they got 2. Then they simplified and made it into a mixed number. 3 divided by 2 gives you 1. 1 times 2 is 2. So that gives us a remainder of 1 over our denominator. That's a lot, right? So that quotient is 3/2 or 1 1/2. So now it's your turn. Let's try this. We have to change to an improper fraction. Whole number times the denominator. So you're saying 1 times 3 plus 1 all over 3 is going to be divided by 2 times 15 plus 2, because that 2 is your numerator, all over 15. If you need to show all these steps, show all these steps. It doesn't hurt, right? 1 times 3 is 3. 2 times 15 is 30. Then we have to simplify our numerator. So 4/3 divided by 32/15. So if we're really breaking it down step by step, it takes us this long to even get to our division problem, right? Now we've got to follow our division steps. We keep the first, so I'm rewriting the first. What am I changing my division to? Division changes to multiplication. And then I have to flip my second fraction. So 15 now goes to the top and 32 goes to the bottom, and they gave us beautiful numbers. Looking across this diagonal, what can I divide both of them by? They share a common factor of 4. 4 divided by 4 is 1. 32 divided by 4 is, across this diagonal, they share a common factor of 3. So if I divide 3 by 3, I have 1. 5 divided by 3 is, 15 divided by 3 is 5. I got a little ahead of myself. Now I'm just multiplying across. If you need to see this, write it. This is 1 times 5. This is 1 times 8. 1 times 5 is 5. 1 times 8 is 8. I can't simplify this any farther, but I do need to decide if it's positive or negative. My signs here were different, so my answer is going to be negative. It's a lot to account for and a lot of steps, right? This took me 4, 5, 6, 7 steps. A lot. We have to be able to put all these things together, right? All right, so terminating decimals, again, if they're terminating, we can use decimals or fractions. If they're repeating, we can only use fractions. Same thing like we had with addition, subtraction, and multiplication, we now have with division. That's all that's saying. All right, remember that fraction bar simply means divided by. So we would rewrite with parentheses the A divided by the B. Then we would put in that 3/4 here. And then honestly, it looks like they're just changing your 3/4 to a decimal because it's terminating. What is 3/4 as a decimal? Remember, we say 3/4, which is 75 cents or 75 hundredths. Excellent. Many of you are catching on. And then I would just put that into a calculator. Even though you should be able to do long division with these, we're not going to make you, right? So when you put that in, out pops out 15. Your signs are different, so your answer is indeed negative. Okay? Now, here they are doing it with fractions. When you have a fraction divided by a fraction, you would rewrite it as 3/4 divided by that fraction. Then we have to multiply by the reciprocal or the multiplicative inverse. So we keep it, we change to multiplication, and we flip it. I'm going to keep this as a fraction because it helps me to see what's on the top and what's on the bottom instead of just changing it to -20, okay? So I have 20 over 1. That way, now I can see that 4 and 20 share a common factor of 4. So when I divide the 4 by 4, I'm at 1. When I divide the 20 by 4, I'm at 5. They're saying 3 times -15 here is -15 over 1. And we would simplify to know that that equals -15. If I have to divide 15 pieces of candy for one person, that person gets all the candy, right? So let's look at this. This you could solve both ways because -2 and 2/5 is terminating. So you can definitely change that to a decimal. So I always put parentheses before I substitute my values. And for x here on top, I'm writing -6 and 85 hundredths. So we know that 2/5 is the same as 4/10. I feel like they use this often. -2.4 here. Now, if you were just estimating and you just kind of went like this, you're thinking you're going to have somewhere near 3, right? It's always good to use those estimating skills just to have an idea of what you should expect. So then I would put it into my calculator. You can put the negatives in or know that when your signs are the same, it's positive. So here it's positive. So I would say 6.85 divided by 2.4. 2 and 85 hundredths, which is close to 3 like we were expecting. Oh, but what happened? We ended up with what? We actually ended up with a repeating decimal. What number is repeating here? The excellent job seeing that they rounded that last digit place up. So that's how I would write that. Now it says, if your answer is in decimal form, round to the nearest hundredth. Remember, we need to know what the hundredth is. 10ths, hundredths. So I look beyond it. If this is 5 or more, I would round up. If it's not, I drop it and keep it the same. Am I rounding up? Nope, I'm dropping the rest and keeping the same. So this would be my correct exact answer because they asked for it round to the nearest hundredth. And that tells you we don't want any digits past the 100th place, okay? Awesome. All right, my dears, we are going to look a little bit. I just want you to try 1 or 2 before your long weekend. Okay, we will have some time to finish up on Tuesday as well, but I definitely want you to look at page 219. This is page 219. Try a couple of these out. Remember, keep, change, flip. Okay. Give these a go. At least get one done. You guys got a few minutes.